Hello, everyone, and welcome to SF Pug December Meetup. I'm your host, Catherine Saar. Before we begin, the meeting is being recorded and will be posted on YouTube afterward. Everyone who speaks during today's event will be part of the recording. We will do the Q&A at the end of the presentation. If you choose to ask a question, your voice and image, if you have your camera on when speaking, will be part of the recording. If you do not ask a question, you will not be part of the recording. If you're using the most recent version of the app, which we recommend, you can use the raise hand function to join the queue. If you're using an older version of the app which does not have this function, please use the chat to let the organizers know you would like to ask a question. They will be able to add you to the queue. The organizer will let you know when you are next in the queue so you can be ready to unmute your microphone and ask your question. If you do not want to be part of the recording, the organizers can convey your question to the speaker. In that case, please type out your question in full and let the organizers know you would like them to present it to the speaker. If you have any technical issues, please message the organizers for assistance. If you drop out of the meeting and are unable to join, you can post a message on the event meetup page, which we are monitoring during the presentation. SF Pug Bay Area Postgres is a PGUS affiliated user group, and I'm a volunteer for PGUS. SF Pug is sponsored by PGX, and I work for PGX. And without further ado, here is Christophe Pettus with a first look at PostgreSQL 17.
Great, thank you very much. One thing I would like to ask is if you're not Catherine or me, please turn off your camera because it kind of gets in the way of the recording. Thank you very much. And hang on, let me see if this works. Getting the slide set up here. There we go, and now, okay, are the slides still visible?
Yes, they are.
Great. Okay, actually, for a moment, I'm going to turn off my camera while I'm presenting. And back to it. Great. Okay. Thanks, everybody. Sorry for the small delay while I worked out the tech. My name is Christophe Pettus. I'm the CEO and lead consultant of PGX. We're a small, we like to say boutique, Postgres consultancy based in Alameda, California. And we're going to talk about what's new in PostgreSQL 17. So let's just dive right on in. Postgres 17 was released back in September. And we're currently on version 17.2. If you are running 7.0 or 7.1, I suggest you upgrade. 7.1 was was a out of cycle release to fix some bugs. They're not. If you haven't experienced the bugs, you're okay. They're pretty obvious if you hit them. They aren't data corruption level things. Your data will be fine no matter what. 17 has a lot of stuff in it, and so we're not going to be able to get to everything, but I will certainly do what I can. We're going to talk about, break it down as SQL improvements, performance enhancements, database administration improvements, some miscellaneous things, and some things that are breaking changes, because it wouldn't be a proper Postgres major release without some breaking changes. Okay, SQL improvements. So the merge statement was introduced in version Mumble. I don't remember actually which one it finally dropped in. The merge statement, if you're not familiar with it, is a way of taking one table and kind of merging, I guess that makes sense, into another with different operations depending on different conditions. This is taken out of the documentation where we're taking a table called new wine list and merging it into wines based on matching up rows by wine name. So you can see there. And we can put in operations that say, well, okay, if it's when not matched by target means there's no matching row in the target, then insert it. If it's matched and the stock numbers are different, update it. And when it's not matched by source, then delete. That when matched by source is new in version 17. So when not matched by source, excuse me. So you can take action if there is no matching row in the source table, not just in the target table. This is an extension to the SQL standard. So it's pretty cool. One thing to be aware of is if you specify both not matched by source and not matched by target, it will have to do a cross join between the tables. So if one's 10 million and one's 1 billion, maybe you don't want to do that.
Christophe, can I interrupt you for a second? It seems like the slides are not progressing on our end.
Okay. Are they now?
Yes, now they are.
Okay, I guess the full screen wasn't working. So for purposes of the recording, I'm going to go through it. Everybody can appreciate these wonderful slides. Pink. Okay, moving on. Also, Merge has now added a returning clause, like say delete and insert both have an update. All have returning clauses that will let you return rows back from the merge statement based on pretty much anything, the expressions that involve both the source and the target table. There's also a function that only works inside of merge called merge action that will return a code as to what it actually did with that row, whether it inserted it, deleted it, or whatever. So that's very handy. Okay, the copy statement. The copy statement has a new option called on error. This is kind of revolutionary. This has really makes a much bigger difference. Big difference because previously, if a row was erroneous, it couldn't parse it by whatever format it was importing on. It just stopped and threw away everything it did. So if you were importing a billion rows and the third to last row had an error, oh well, you lost the entire billion row import because it's all running inside a single transaction since it's a single statement. You now have the option to ignore errors, and it will just keep trucking on if it finds a bad row. It writes a notice at the end of the operation. It raises issues a notice level log entry saying what the saying how many it specified. If you set log verbosity equal to verbose, then it will log the row number and bad column for each error. You can also set log verbosity at the statement level, the session level, so you can issue that right before you do the copy. You don't have to set it globally across the whole server. All sorts of new JSON things. There's a SQL standard function JSON table. Which queries a JSON object and returns the data inside of it as a relational table. It uses the SQL JSON query language, and it's a set returning function. So you can join against it, do these things. I do ask you only use this power for good. If you're doing lots and lots of joins all the time on JSON blobs, maybe make them relational data. So here's an example. This is also taken from the documentation. So you see select JT, which if you look then way down at the end of the query, JT is the alias for the JSON table function call. You have to specify what table is the column that is the JSON blob is. So in this case, my films. And then, JS is a field of my films. And then you have this exciting multi-line multi-entry column statement that specifies the columns that you want to come out of this query. So ID for ordinality, which is because the SQL standard can never put anything concisely. That's the sequence number. And then we have a text field which we pick up using the path $kind. I'm not going to go too deeply into the SQL JSON query language because it's pretty extensive, but pick up the kind object field out of the top level object, then the films array, basically for every key films, we're going to pick up from that object the title and the director. With wrapper means if more than one thing comes back, put them in, wrap them up in an array. So you can think of it as kind of like arrayag function in Postgres. And here's what we get. So there's text columns, title columns, nicely wrapped up in arrays. So it's very handy if you have quick, operations that you want to do on a JSON blob without unwrapping it into relational data. But again, if you're doing joins and that kind of thing regularly on this data, you may want to consider moving it to relational data, because obviously there's only so fast this thing is going to perform. So we have more JSON functions. We have the SQL standard JSON cast, which takes a character representation of JSON and returns the internal representation. You can think of it's basically a more standard compliant version of the 2_JSON that we've had forever. There's a JSON scalar which takes a JSON style scalar, which is to say a number, a Boolean, that, and it turns it into it takes a SQL style scalar and turns it into a JSON style scalar. Not 100% sure when you'd use this, but it's there if you want it. And JSON serialized goes the other way around. It takes a JSON object and writes it out as either a string or a byte A. So now we have these SQL standard compliant functions. Then there are these functions that use the SQL JSON query language. Exists just tests to see if anything comes back from the query and returns a Boolean, yes or no, kind of like the exists operator in SQL. The query returns returns the results from the query, and it can return multiple rows, and the value either returns exactly 0 rows, in which case it's null, 1 row, or it returns an error. So that if you're effectively asserting that only 1 row will come back from this, 1 value will come back from JSON value. Okay, explain has 2 new options, and the first one is explain memory, which adds to the explain output the amount of memory that was used during query planning, not during the execution of the query, just planning. So we do this big old sequential scan, and it used 17K or 7K, excuse me, for planning. This can be, obviously this is a trivial example, but this can be handy if you see things starting to take a lot. If you see a query seems to be consuming a lot of memory and you're curious where it's going, you can, sometimes query planning can take a lot of memory, and this will help diagnose that. Another option that it was added is serialize. This has to be run with analyze. You can't run it on just explain. And it adds the time required to serialize the output to the client. So traditionally, query execution did not include this time, but this can be a significant portion of the overall query execution time. And so this nicely breaks it out. So here, for example, we see that we select from this very large table. The planning time is, nothing. The execution time is just under 9 seconds, of which over 3 seconds was the time necessary to write the data out to the client. This doesn't include network time. This is just the Postgres' time to shove it into the pipe, not how long it takes for it to get over to the client. So here we see that over a third of the time was just doing serialization. You can add you can say serialized text or serialized binary, depending on if you're analyzing different kinds of clients. Different kinds of clients will use could use text or binary output. And for example, doing the same thing with binary, let's see. That's probably a cold cache, hot cache problem. That's very interesting. The whole thing did take longer, but a smaller percentage of the time was serialization time. But, and just for completeness, here we were returning exactly one row, and we can see the serialization time was like nothing compared to the execution time. So this is highly dependent on how much data gets returned, especially if you're returning things like large toasted things like giant text objects. This could be significant. Okay, everyone take a deep breath because we're about to talk about collation providers. So collation and locales in general are kind of a complex topic in Postgres, and I'm actually doing a whole talk just on that at the February Pug and at Scale down in Los Angeles in March. But here's a quick summary. So what is this thing, a collation provider? A collation provider is a library, binary, piece of code that Postgres loads that provides functions that sort text based on the locale. The locale can be the language, the region for languages, and perhaps other options. Like, for example, might be collation can be case insensitive. Specialized ones like German phone book order, which is different from other kinds of German collations. Before version 17, there were two libraries Postgres would use to provide collations. libc, the implementation of the C standard library. Almost everyone knows this as glibc, the new version. And since version 10, you have the option of also using ICU, which is from the Unicode consortium, which so this is it only works on Unicode, which libc can work on other character encodings, but really, if just encode all your databases UTF-8, and problem solved. And it has a lot more flexibility and options than libc. And you could use that as a collation provider since version 10. So most of the time, we just accept the collation system uses. When you see this en_us.utf8, that's locale. It also is the name of the collation it's using. Once in a while, if you go out onto the internet and look at like things like Stack Exchange, you'll see that advice is saying don't use any of these complicated, fancy linguistic collations. Just use the CPOSIX one. Don't take that to heart. That's I think now obsolete advice. So why do we care about all this? The problem is, collation is very important, obviously, in a database. It's how order by works, and it's also how indexes are built. But libc and ICU are external libraries, so they can change, even on the same database server. But that doesn't automatically rebuild the indexes. And suddenly the indexes, the sortation you get in the index isn't the sortation you get by order by. And this effectively corrupts the index because you'll get weird results out of it compared to what you expect. And this happens in real life. glibc 2.28 significantly changed enough collations that people were getting weird results when they, for example, upgraded Ubuntu to a new version, but kept the database or the binary database the same. And this could be very troublesome because effectively your database is now behaving badly. So what you do about this is, since version 10, Postgres has, if you were using a version of the ICU library that on the system, there was a different version of the ICU library that was used to build indexes, you get a warning. And warning you to do a reindex. And since version 15, Postgres also now looks for libc versions. It will tell you if any libc version changes happen, even if because it doesn't really know if that means a collation change or not. But to fix this, you basically had to do a reindex of all the text columns. And of course, in a large database, that's really painful. So what's an alternative to not having to do this? Well, version 17 offers an alternative, which is there's a brand new collation provider called Built-in. It provides exactly two collations, C and C.UTF-8. Those are guaranteed never, ever, ever to change. C is basically a wrapper around string comparison. Now, without going into horrible details about character encoding, that works great as long as every single character in your database is a 7-bit ASCII character. As soon as you have non-7-bit ASCII characters, your collation is going to it'll work. Nothing will break or anything, but your collations are going to look really weird because those 7-bit ASCII characters are not going to collate the way a natural language would expect. If you're using UTF-8 as your encoding, which you should, the CUTF-8 collation compares the actual Unicode code points, so as if they were the 32-bit Unicode code points. This works better, although not perfectly. I recommend just using C.UTF-8 if you don't want to use a real linguistic collation. So the sortation will be weird, but it'll be less weird. And so it's very, very, very unlikely that this will ever change. So this means you're freed from having to worry about libc or ICU version changes at the cost of having collations that aren't going to line up with people's expectations of how their language should be sorted. Here's how you create a database using it. You set your encoding to UTF-8, the locale provider to built-in, say the built-in locale to UTF-8 or whatever. Note you have to specify template 0 if you're doing this, because template 1 already has a locale associated with it, and it won't let you change that, because once you set the character encoding and the locale for a database, you're stuck. The only way to change it is dump restore. Just as a note, people say that the CPOSIX locale is the fastest, and they're right, but not by much. You notice the CUTF-8 collation is really within noise, within the margin of error, as being exactly as fast as POSIX. The IND-XICU locale, which I added there, it's an ICU locale. You can create your database using it, or even down to an individual column if you want. And it's slower, but it's not that much slower, and you get a much natural sortation order. And then there's the the Austrian-German locale, just by comparison, which is not really any different from the IND-ICU collation. And you see libc kind of trails rather badly in terms of performance. So the moral of the story is either use built-in if you're building a new database or want to change one of your existing database, use either built-in or ICU. There really isn't a good reason to use libc anymore. Speaking of performance, let's talk about performance. There are lots and lots and lots of performance improvements in version 17. Most of them, there's nothing to look at or control. They just work. Just your database moves faster. And there are changes to the I/O subsystem that take more advantage of more modern I/O constructs, like scatter-gather I/O and things like that. Better and more intelligent query planning, all sorts of great stuff. So you get it for free just by upgrading to 17. Some specific ones is vacuum and auto vacuum have had lots of improvements, including significant speeds up on vacuum freeze. So vacuum freeze has gotten much more efficient. Vacuuming in general takes a lot less memory. There's also, in the case of a table with no indexes, which admittedly is not super common, there's now a fast path that goes really fast. Vacuum can use more of maintenance work mem and auto vacuum work mem than it could before. So if you've set these fairly high, it will make better use of it than it did before. It was hard to get it to use more than a gigabyte before. And no configuration changes required here. It just happens. So one of the things that has improved a lot over the last few major versions of Postgres is the implementation of B-trees, which is kind of funny because you think of all the things that were like settled technology, a B-tree would be one of them, but lots of things have improved. So for a lot of these, you do need to rebuild the index to get the advantage of it, but it's often worth upgrading. I'd say definitely worth upgrading just to get these improvements. In this particular version, there's improved performance when querying lists of values. For example, an in clause that has a large number of values in the in clause. And this is a very common pattern. You see it a lot, especially in generated queries. So this is will be a real life benefit for everybody. So one of the things that seems like a small improvement, but one of the things that has always sometimes frustrates new people with Postgres is they will query a not null column with is not null, and Postgres will dutifully check to make sure the not null column is in fact not null. It'll actually apply the predicate, and people say, well, why can't it be smart enough that it just skips that because it can't be null? It's declared not null, and now finally Postgres will do that. Very few humans write queries like this, but frequently query generators will add these somewhat gratuitous is null or is not null columns to it, and now Postgres is smart enough to optimize those. So if you query a not null column with is null, Postgres will just say, okay, no, 0. I can figure that out without even looking at the data. And there's lots and lots more. We can measure up to 30% improvement in throughput, especially on real-world index-heavy workloads. And honestly, most real-world workloads are index-heavy. And there's more improvements coming, especially in the I/O subsystem. So version 17 is definitely worth it just for a performance basis. Okay, and let's talk about database administration. Okay, any really experienced Postgres DBA has run into this where everything seems to be working fine, the birds are chirping, the sun is out, and then suddenly Postgres grinds to a halt with some kinds of lightweight locks that have the abbreviation SLRU in them out of nowhere. It's not super common, but in a career in Postgres, eventually this will happen to you. The short form of this is Postgres has a lot of internal caches to cache various kinds of accounting structures that it keeps track of. These traditionally have all been fixed size in memory, and if the in-memory one fills up, it spills everything to disk. That threshold of going from in-memory to spilling to disk was a cliff edge for performance very frequently. And there was no way of changing these except to recompile Postgres, which, who does, most people don't do that. So this is a problem that has been struggled with for every version. Now they can be configured at server start time. Yay. This will help clear up a lot of these issues. You can configure pretty much all of them using parameters in PostgreSQL.conf. The most critical ones by default are configured based on shared buffers, so they expand as you give more memory to shared buffers. Just accepting the defaults will help mitigate a lot of these weird problems if you've seen the subtrans SLRU lightweight lock and things like that. The two most common situations where these pop up are when you have lots of subtransactions or a large number of foreign keys to a single record. And these are not uncommon workloads, so this will help a lot on this. And the good news is you don't really have to spend a lot of time tuning these. In fact, I wouldn't until you have some experience with them. Just bringing up Postgres in version 17 you get this feature for free. One of the things that has been an ongoing problem about logical replication is when you want to do a major version upgrade, effectively all your publishers and subscribers get dropped, which means all the state that was in them get dropped. And frequently you were put in the situation you had to reinitialize an entire subscriber in order to do an upgrade or things like that. This PG upgrade now preserves the state of publishers and subscribers, which means you don't have to rebuild logical replicas after a major version upgrade. So it's a very nice change. So for people with experience with PostgreSQL logical replication, there's this thing. So you want to build the logical replica. So you configure this. Generally what you do is you take a snapshot of the schema with no data in it, install it on the replica, set up a publication on the publisher, set up a subscription on the subscriber, and then you go away for 3 weeks because it has to copy all the data from the publisher to the subscriber to bring it up to sync. And this can take a long time. Firing up a binary replica can be much faster for a variety of reasons, and in part because you're just moving around a disk image, not sending individual rows and things across. And so we now have a new tool called PG Create Subscriber that will take a binary replica and turn it into a logical replica, no data copying required. It's amazing. There are some caveats, though. Read the documentation very carefully. There are lots of prerequisites and caveats to PG Create Subscriber. I can summarize them by saying you probably want to create a binary replica specifically for this purpose, not just take your some random binary replica that's already running and use it on that. The biggest disadvantage from our perspective right now is that the subscriber has to link to a for all tables publisher. For all tables is a way of creating the subscription that says not just add all the tables that are currently in the database, but every time you get a new table, you create a table that automatically gets added to the publication. That can be complicated operationally because you have to remember to you always have to remember to create the table on the subscriber first, and there are other issues. If you didn't see Casey's talk last month, she talked about how this can mess you up. So that is a big limitation of it. But if you're willing to accept the problems that come with for all tables, it's a much, much better way of creating a subscriber. Okay, Postgres has in-core incremental backups. Woo. Built based on the PG base backup tool. Most people are familiar with PG base backup as a way of firing up new binary replicas, but it is a backup tool. You can use it to back your database up just fine. And the way it works is when you do a full backup, like you do now with PG base backup, you get a manifest file that you then feed back into PG base backup using the incremental option. And it will try to only back up the blocks that have changed since the manifest file was created. It does this by interrogating the wall, but the good news is you don't have to keep the entire wall around for this to happen. There's a summarization process that happens if you turn on summarize wall, which is a condensed version of the information it needs to know how what blocks it needs to copy. You can then there's then a combined backup tool that can take a full backup, apply the incremental backups to it, and restore the system from that. So this works and it's great. If you're currently using a tool that does this already, like PG Backrest, it's not clear you should abandon everything and move over to it. But this is a very handy facility and one that will enable more sophisticated backup infrastructure like Backrest to do things more easily. This is a small one, but one that it speaks to my heart, which is PG Dump. You can filter out, you can include and exclude tables by glob patterns, but previously you had to do it all in the command line, which was annoying if you had 50 tables that you wanted to dump or exclude, and you had to add them all as -T options. Now you can it can take them all out of a file. That's just it seems small, but it'll be surprisingly convenient. There's a brand new permission on tables called maintain. Previously, there were operations that only the owner of a table could do. Vacuum analyze, reindex, blah, blah, blah. Now you can grant the ability to do these to a different role, which for installations that have a very sophisticated role structure and don't want to use the owner role for a lot of things, which is a reasonable security precaution to take, you can now create a role that only does this kind of thing, and that's a very nice extension. So yeah, event triggers. Postgres has had event triggers for a while. These are triggers that don't happen on the basis of data modification, like traditional statement and row level triggers, but when events happen inside the database. I guess the phrase event trigger was kind of a giveaway there. Previously, you could set a triggers on DDL command start and end. So when like a create table was issued, table was dropped, or or a table was rewritten. Now there's a new one called login, which is both very powerful and very dangerous, because you can write an event trigger that will fire anytime a user logs in. This is great for things like auditing purposes or setting up customized environments or things like that. The thing to remember is if that trigger gets an error, that user is you can't log in. If it gives an error for every user, no one can log in, including super users, and you've just locked yourself out of the database. Excuse me, locked yourself out of the database. The only way to fix it in that case is to set the parameter event triggers equals off and restart the database, and then remove the trigger or do whatever. So be cautious with this, because you can, in fact, create a situation where you lock yourself out. And if you're in an environment that supports event triggers but is hosted where you don't have necessarily have access to all the parameters to change, be very cautious of it. And this is just handy. There's a new pretty much static table called PG wait events that gives a description for every wait event, so you can join against it when you're doing monitoring, and it'll give you an actual description of the event rather than just the somewhat cryptic name it has. Okay, and there's a slide of miscellany. libpq will now let clients change passwords, which is kind of nice. You PG admin or something like that, you can now have a change password dialog box. Brin indexes can be built in parallel, which is useful. Vacuum, the wall traffic on Vacuum has been significantly reduced, which is great because a vacuum operation could create a ton of wall, which can slow down, which could choke binary replicas, of course, but even logical replicas, because they have to the replication framework has to take time to look at them and through the records and throw them away. You can cancel a transaction based on how long it's been running. So you can think of this as conceptually one step up from statement timeout. So instead of an individual statement, it will be the whole transaction. And it doesn't matter if the transaction was idle or running. So it serves a different purpose than idle and transaction timeout. Partition tables can have exclusion constraints. That's nice. And intervals now have plus or minus infinity as actual options they can have. Previously, you had to kind of fake it with big data or something. Okay, and of course, breaking changes. This is probably the one that will trip up most people, which is changes in the way search path is handled. Specifically, maintenance operations don't use the search path. So if you just type vacuum or analyze or something, or more usefully create index, before it would use whatever search path you were running as, so your local search path. Now it always runs with a minimal search path, PG catalog and PG temp. This is for security reasons, because if you didn't do that, suppose you had a functional index, something index built on top of an expression. If a nasty person could come in and create a new function ahead in the search path with that same name and make you run it when you did a reindex or something like that. Admittedly, a very small attack surface, but it could happen. The problem is that now its lookup mechanism may not find functions that aren't schema qualified. Now, so the solution here is to either explicitly qualify functions that don't live inside of PG catalog, or set search path to the function. You've needed this for a while for PG restore to work properly anyway. So this is not, in some sense, a new change, but it will crop up more often because it happens at times other than when you're running PG restore. Here's an example of something that doesn't work. I just create two small functions, one calls the other, and all they do is pass the value along. And then I create an index. I try to create an index on the second one, but it can't find the first one because it's turned off the search path that includes public, which is where these would be created by default. And so when it's trying to recreate the index, so this could be very surprising because you're looking up and saying, well, I was able to select from it. Why can't it create it on it? And that's why it uses that minimal search path. However, you can fix this in one of two ways. One is you can just schema qualify the function and say public dot, and that works fine. Or you can set a search path on the function itself, and it'll adopt that search path when it runs, and that works fine. Other breaking changes: AIX is no longer supported because AIX is weird. Talk to IBM about it. Every major release, the system views get rearranged. Columns get added, columns get dropped. This generally only matters if you're running, if you're doing monitoring, because those are the things that really need to know that schema. Don't use system views as part of normal application operations. I just had to debug an application where a standard operation based on their queuing system was joining against PG locks, and bad things were happening. So only use these for their intended purpose. And that's everything. Thank you very much. And there's lots and lots more that I couldn't fit into this, so download it, try it out. Version 17.2 is fine for production. It's a very stable release. And as always, check the release notes because they have everything in them. And questions?
Do we have any questions? That was a lot of really good information.
Yes, the slides will be available.
Awesome.
And at my website, which is thebuild.com.
Perfect. Anton gave us a thumbs up, and yeah, I think that I would say we probably don't have any questions. Karen says, thank you. That was really useful. Thank you, Karen. And thank you, Tobias, for the thumbs up. All right. Thank you, Christophe, for a great talk. Thank you also to PGUS and PGX. Upcoming events: SFBAPE Hug is going to be coming up Tuesday, January 14th with BM25 full text search in Postgres via Tantivy with Philippe Noel. And then coming up in February, on February 11th, we have Language as a Virus, Managing Locales in PostgreSQL with Christophe Pettus. Upcoming conferences are FOSDEM in February 1st and 2nd at the University of Belgium, Scale 22, March 6th through 9th in Pasadena, California, PG Day Chicago, April 25th in Chicago. We will send a link by email when the video is ready, and watch our social media. You can find us on Twitter, LinkedIn, Mastodon, and Blue Sky by searching for Bay Area Postgres. We are looking for speakers for 2025, so if you or someone you know is interested, please contact us. Thank you, everyone, for showing up today. If you have any questions, anything, you can always ask them in the comments section on our meetup page. I hope everyone has a great rest of the day, and we will see you in January.